Hello and welcome to another episode of the DigiTeacher. In this week's episode, I'd like to do another lesson idea for using with the Scratch programming platform. So when you're introducing computational concepts, you want a range of different types of projects that you can put together, and you can highlight the particular concept that you need. So it's very useful to have a library of projects that you have on hand that you can reach into, especially if you see that you might have introduced a particular concept in one project, but you can see that the students haven't really got it yet, and you can get them to do another project which uses that concept and reinforces it, gives them some time to consolidate that concept. So it's very useful to have this library of projects, and this is one idea. Getting students to create their own games, I think, is quite motivating, and especially it's motivating because you can kind of tackle design elements as well. Get them to design the game independently of then coming and coding the game. Then you can produce the kind of starter code that's necessary. It's a good pedagogical principle, I think, to get students to read code and understand code before they create their own code. So the way I put these projects together is very much to introduce the starter code, show them how to do a certain thing. For example, how to get a ball to move around a screen, bouncing off the walls, how to get a paddle to hit the ball, how to add a score variable whenever you hit the ball, how to end the game when the ball gets past the paddle. And then challenge students to make a two-player game of Pong, for example, where you have two players, each with a paddle, hitting the ball against each other, using it to bounce off the walls. And you can add extra levels and all kinds of things to that. So the whole idea behind this particular project is it's part of a library of code ideas, game ideas that you can pull out and use when you need that particular concept and you need to reinforce that concept. So without further ado, I'm going to head over to Scratch and show you the code behind that, and then you can decide how you want to get students to modify that and take it further. Okay, so in Scratch I've set myself a background. So I've added a background here. I've searched and created this background, and I created a variable. So under variables I make a variable, and I made a variable called score. I've ticked it here so that it shows on the screen, and that will keep track of the score. So Pong is a game where you have a bouncing ball. So I'm going to go to choose a sprite, and I'm going to type in ball, and I'm going to go and get a ball. I'm going to use a basketball, and what happened? Why did my basketball? There we go. And you position it somewhere on the screen, and now I need to get it moving. So that's under motion. Well, first of all, I have to have a when flag clicked, and motion, if it moves a certain number of steps. So when I click the flag, you can see that the ball moves, but then it stops. So it needs to be in a forever loop. So under control, I go and get my forever loop. There we go. And I just put it around there. So now it moves those 10 steps until it hits the edge. You can increase the speed just by increasing the number of steps that it moves in that split second. That would increase speed. So that's one modification students can make, setting the speed. They could create a speed variable, for example, and then as you go up a level, the speed could increment. That's one way of doing it. So we've got the ball moving, but if you look at it, it's just stuck on the edge. So now we've got to go into our motion and go to if on edge bounce and add that. And now the ball moves in the horizontal plane, and you can see its X value is changing here, but not the Y value. We want it to bounce all over the screen. So one way of doing that is to go to point in direction, and before the forever loop, you just change that. It's at 90 degrees by default. That's why it's moving in the horizontal plane. I could move it up to 45 degrees here, and then you can see it's bouncing like that. I could put a slightly random number in here. So I could go to random is under operators, and I'm going to pick a random number. So it should be roughly 45 degrees, so maybe put 40 to 50. And so each time that the game is played, it's going to have a slightly different angle as it comes off the wall and as it bounces around. The score is presently on 1, so I need to change that at the beginning of the game. So I go into variables, and right at the beginning I'm going to set my score to 0. So that resets the score to 0. My ball's now bouncing around, so now I need to put in a paddle to hit it with. So I go to choose a sprite, and I can search for a paddle. I could also draw one if I wanted, and obviously I can modify the color of the paddle. And there's the paddle. Now the paddle we're going to have moving up and down on the bottom of the screen, and obviously you can reorient it, changing the direction and so forth, and you can change the size of the paddle. So maybe in the first level the size is 150, so you make the paddle bigger, and then as you go up levels you can change the size of the paddle and the direction there. If I wanted to have a paddle going like that for a game where 2 players play against each other, I could do it that way. And it's a good idea. You can show students how that works, and then you can challenge them to make their own game, to modify it. So once I've got the paddle, I've got code for the basketball. Now I need some code for the paddle. And what I want the code to do is, as I move my cursor, I want it to move. So I go to when clicked, it's going to be in a forever loop, and it's going to be a motion, and it's going to be setting the x-axis. So the x-axis is the horizontal axis. I don't want the y-axis to change, but I need to set the x-axis. Now I can't do it manually. I can only do that by moving. So I can kind of move it around like that, but I want it to move with the mouse cursor. And to do that, I can go to sensing, and I can use mouse X. So it's setting the X value of the paddle to the mouse X, and it's doing that inside of forever. If you want to, you can kind of do that, start the game, and you'll notice it jumped there, and then when I move the cursor it's not working. Why? Because it's not listening anymore. So you can deliberately make mistakes and then ask students, well, how do we fix that? Well, you would fix it by putting it within a forever loop, and you can kind of prompt them on that. So now as I move my mouse up and down, the paddle moves in the horizontal axis, not in the y-axis. So that's my paddle code. But I want the ball to bounce if it hits the paddle. So that's ball code, so I'm going to click on the code there, and I'm going to make it in a separate control, separate event. So it's going to listen out. Again, it has to be forever, because it must constantly listen out for hitting the paddle. And then it's going to bounce off the paddle if the ball hits the paddle. So if the ball hits the paddle. And one technique I use with students is to kind of use language as a pseudocode. So I try to encourage them to think and imagine that they are the computer. What must I do? Well, if the ball hits the paddle, then I must. And that becomes their pseudocode, and then they unpack each bit of code. Well, you can hear the if there, so we're going to use an if statement, and then the condition is if it hits the paddle. So that's about sensing, and that's about touching. So we clicked on the basketball, so it means if the basketball is touching the paddle, then it must do something. Well, it must bounce, so that's motion, and bouncing is about turning a certain number of degrees. And you can kind of take that, leave the default 15 degrees, and as it hits it, you can see that didn't work at all. So they can kind of play around, and they might find that kind of 90 degrees works better. So it kind of changes 90 degrees, and that seems to work. There's a kind of odd little bounce sometimes, but that seems to happen. So 90 degrees seems to work. 180 degrees would also work. So you could kind of play around with a number of degrees, and you want it to change score when it hits the paddle. Now it's probably a good idea to get it to just leave the paddle before changing the score. So you can add a little wait in there. So you can have a wait of kind of like half a second or something, and then have the score change. So that you would do under variables, and you would change the score by 1 or 2 or whatever you want to do. So you can see now it reset to 0, that's fine, it hits the paddle, and the score kind of waits a second and then it changes. So that seems to be working, and I seem to be able to hit it off. Maybe 90 degrees was better. And you can get students to look at the game and kind of think, well, what's wrong here? What do we want to happen? Which part of the code do we need to change? And you can get them to get used to the idea of modifying and debugging by doing that kind of thing. So that's working, but I want to end the game if it gets past the paddle, if it beats the paddle. So to do that, I need to add another sprite. I need to add a line. Whoops. And I can choose that red line. And I can go and add that to the bottom of the screen. Again, I could just change the size or the direction if I wanted a line here and another line there. Now the whole idea is I need some code now so that if it touches the line, it ends the game. So to do that, I go to my events. I have another onClicked. Again, it's a forever loop. It must continually listen out for this event happening. And again, it's an if it hits, and it's touching. So if it's touching, so this is the line. So if it touches the ball, if the line touches the ball, then it's game over. And game over is a control. So there we go. You can use stop all. So stop this script. So it's stopping everything. So the game ends if it beats the line. So let's start the game again, and it hits the line and ends the game. So if it's touching the basketball, I might want to add maybe a little game over. So get the basketball going, there we go, and it hits, and I couldn't see the game over, so I'm not quite sure why that code didn't run. Anyway, you'd need to kind of tweak that and get it to work. Logically, if it touches the basketball, say game over. No idea why that didn't work. Maybe it needs a pause. Probably needs a pause, doesn't it? So if it waits a second and then, let's just test that. There we go, and it says game over, and then it stops. So that's quite a useful way also of making deliberate mistakes. That wasn't a deliberate mistake. That was me kind of thinking through the code and why it wasn't working. But you can make deliberate mistakes, present them to students. For example, putting the stop all outside the forever, and then the game just stops without listening for the condition. So you could put things in the wrong place and get students to think through why it's not working in that position. So this is all very kind of useful code for a game that you can get students to then play with and modify. So you can ask students now, how would you add another level? You need another backdrop, and you need code that when the score is, so if the score is greater than a certain amount, it changes the background, maybe adds to the speed, stuff like that. You can add 2 paddles for 2 players, and so on. So designing different games, getting them to play a game based on this is all very useful stuff. Maybe not having a basketball, but having a little beetle, and you're running around with a butterfly net. So you can use this kind of starter code and challenge them to create their own game based on this. They're using certain principles, they're reading code. You're trying to build mistakes into the code so that you get some experience and you can kind of model the thinking around debugging with them. As they get better, you can ask them to debug more and more and more. So for the first few lessons, the first few times I do this kind of thing, I tell them, what's wrong here? And if they don't get it, I kind of supply the answer quite quickly. And then later on, you can say, this code is broken. I don't know how to fix it. It's over to you. And you can get the groups sitting together, peer programming or whatever it is, trying to figure out where the code is broken and fix it. And you can incentivize this by making it a competition. First team to spot the mistake. These are all pedagogical ideas for within a principle where you've got starter code and then you want students to modify the code. I hope you enjoyed this little project and found it useful, and I hope you find it a use in your programming. This code is particularly good for ifs because you're using lots of ifs. So if that's the programming concept, this is a good project for doing that. Well, if you enjoyed this video, then you know what to do. Hit like, hit subscribe, and please leave comments about how you found this useful or not, or other ideas that you have, other games that you'd like to see covered in this series. Well, bye for now, and I'll see you next week again for another episode of the DigiTeacher.